Yes, indeed, we are privileged to show you that this afternoon we're having one of the beautiful mathematics teachers I have had a chance to meet. And they have been teaching all along. Beautiful. Yes. Oh, Mr. Roger, you're most welcome on this episode of Mathematics Live. We have been doing science from the beginning, but now I thought wise that we should have mathematics as well, because the problems of science and mathematics cut across. Science and mathematics have same problems. Let's go straight to the point. What makes mathematics hard?
What makes mathematics hard? One, I'm Rogers, as he has introduced me to you, the viewers. I'm so humbled to have you on this platform. I handle mathematics and I love mathematics. One, the factors that drill children having the ideology of ancestors that mathematics had from the beginning, from the universe.
Come on. You're talking about ancestors teaching their children that mathematics is hard.
Yes.
And there are some ancestors who also taught their children that mathematics is simple.
There are, but a few.
So the number of ancestors who taught their children that mathematics is harder is bigger than the number of ancestors who taught their children that mathematics is simple. Come on, explain them.
Then by mere coming to school,
and
they prove that mathematics is a fact subject.
All right.
It's a fact that you talk of facts. So if you don't know how to deliver the facts to the children, they pick nothing and they start believing their ancestors.
Does it mean that mathematics has bad teachers, or those who teach mathematics don't understand it?
I wouldn't say they are bad, but it's giving what you don't know. You can't give what you don't.
They really teach what they don't know themselves.
So they teach what they have crammed, but they don't teach what they understand.
They get materials from books from elsewhere, they just drop it on chalkboard. That's crazy, man.
Not knowing these books are for pupils. For the pupils' book.
All right.
It's not a teacher's book.
All right, now here I'm asking, how do you simplify mathematics?
The way I simplify mathematics to learners is by showing to them that mathematics is what you do. It's a life event that you practice as you're coming to school. You're in integers. As you're coming to school, you're in algebra.
I didn't mean integers coming to school. I'm walking on the road.
Let's assume you have taken 10 steps in front.
Yes.
Then as you move, you realize that you've dropped a coin. Your coin from pocket money. And you're coming back. That's subtraction of integers. Positive is in front and coming back is the negative.
My friend, when coming back, I change direction. I don't come back like I don't walk backwards. I change and face this direction where I'm coming from.
As you change direction, it is negative. As you're changing direction, it's negative. Now, meaning the negative is calling you to change position, which is becoming a positive. And ideally still you may be two. You are moving to school, maybe you are going anywhere with a friend, then you realize that a friend is speaking at a slow pace. You try to turn behind and pick the friend. So as you are coming back, you are trying to solve. That's what we can still call interval. For you are higher than the friend. So the distance in between is what we call range. You can see that it is normal.
Is there any way you can help us illustrate what you're talking on the board?
I can.
Surely?
I can.
Let me switch with the board. Let me switch with the board and then you can help us understand.
As viewers, I can try to say, or I can advise that tell children mathematics is the easiest subject. Because it doesn't require you understanding much. It is a simple fact that a child picks a fact and understands the facts forever. And
Mr. Roger, the board is there. The board is there for you. Let me change the camera like this.
Yes.
The board is there for you. All right. Good.
I welcome you to the board.
Thank you.
I wanted to talk about what we call coordinate geometry.
Please do.
Get another one called coordinate geometry.
What about that? What about coordinate? How do you call it?
Coordinate geometry.
Yes. What about that?
Coordinate geometry is a simple topic in mathematics that calls for application of algebra, calls for integers. In integers, the idea you need is the positive and the negative. And in algebra, the idea you need is substitution. For example, I can have one number here. Complete the table below using the equation of the line y equals x plus 1. Now this is the equation they are giving you, and you are supposed to complete a table of this nature.
Alright.
This is x and this is y. Just as I can help you to demonstrate something before I do anything, that we have what we call a Cartesian graph.
Yes.
And on the Cartesian graph,
Yes.
we have two axes.
Yes.
One is called, the vertical one is called y-axis.
Yes.
And the horizontal one is what we call x-axis.
Excuse me, I have been some of the places and something has been drawn and they put here north, east, or north, west, east and south.
Yes.
In mathematics, do you change north into y-axis or anything different?
It is.
I don't know, because now this is y is running always through. This is x running always through, but when we see compass,
Yes.
north, south,
Yes.
east, west. Tell me about it.
So on the Cartesian graph, we have what we call longitudes and latitudes.
Oh,
But what forms a coordinate is where they meet.
oh, no, no. Go on.
So as they meet somewhere,
Yeah, go on.
now for the Cartesian graph, before including any other latitude or longitude,
Alright.
I've explained that now they are meeting at
This is
zero.
your origin.
Yes.
This is where the story begins.
Uh-huh.
So this line ends here.
Yes. So the x and y coordinate
Here.
would be 0 and 0.
Oh, so this 1, 0 and 0 is here. This is
Meaning, on the vertical axis
Yes.
and the horizontal axis, you are moving no point.
Alright.
This would be 1. This would be 1, which is a negative. Then this would be a negative 1, a negative 2, a 1, a 2, like that. But this is a 0.
Alright.
So at this point here,
I'm
you
supposed
move-
to ask you.
Yes.
You are putting negative here.
Yes.
And in the explanation we had as we are sitting, we said maybe someone was moving this side.
Yes.
So he left the coin behind and he went back to pick it. Can't a person have been moving this side?
You can.
Can the person have been moving this side and the coin was dropped to this side and then he comes to pick the coin from
In normal life, that's why everyone has the feet facing
one
the
direction.
front. Yes.
Oh, come on.
You don't have them forcing the behind part.
So this one demonstrates
So
the direction of the
if someone has to retard, meaning you are supposed to oppose the x-axis of the negative, meaning the feet will be facing this way, but you are just forcing it to come this way. Retarding.
I get you now.
So as we come to the table, we can have negative 3.
Yes.
We have 5.
Alright.
We have a 0 and then a 2.
Alright.
Meaning, they are telling us that this is a coordinate table.
Alright.
Giving you coordinates that you are supposed to plot on the Cartesian graph.
Alright.
But how do you get them? I assume this is Roman numeral 1, Roman numeral 2, Roman numeral 3, then Roman numeral 4. Meaning, for ideas of substituting in, I will have for equation 1. They are telling me x is equal to negative 3. For x is equal to negative 3, what's the value of y? Meaning, the equation is y is equal to x plus 1.
Alright.
So meaning, algebra now comes in of substitution. You have x as negative 3, so y will be negative 3 plus 1.
Alright.
Y becomes, now we have integers. integers are coming in. You have a negative 3 and a 1.
Alright.
Meaning, you can tell that people, that please, a negative and a positive are here. The negative is 1, 2, 3. Then the positive we have only 1.
Alright.
Meaning a negative can go with a positive. Which side is having customers? It is the negative which is having a negative 2. We continue. Roman numeral 2. So after, the question is saying complete. So I have y as negative 2. Y will become a negative 2. So for Roman numeral 2, they are now not giving you x, they are giving you y. That y is equal to 5.
Yep.
So if y is equal to 5, in the original question which is y is equal to x plus 1, where the value of y is where I put 5 to substitute is equal to x.
I'm asking, is it a question of understanding the value of y from the table? For example, then understanding if you have x or not x, then you substitute in?
Yes.
Okay. I'm going to give myself work by looking for the value of this. Go on.
So meaning, it may be looking, but it's up to a child to get the additive inverse of 1 on both sides. The child can arrange the equation originally by saying x plus 1 is equal to 5, which is the commutative part of mathematics. So we can get 5, I'm subtracting 1 on both sides, x plus 1 minus 1.
Alright.
Giving you 4 is equal to x plus 0. Therefore, epsilon is equal to 4.
Right.
Because ideally 4 cannot be equal to x, but it's x which is equal to 4. You complete the table.
Is it fine? Give me chance to calculate this and see if we can as well
Not
try.
very fine, but it's very right and you
Alright.
Try out for me.
Alright. Come on. Or from the equation you say y equals. This is my first time doing mathematics at this HS now.
Yes.
Now you are saying y equals x plus 1. Good. Now on this table, we have the value of y. No, I don't have. So y is what I'm looking for.
Yes.
X, where is x? Oh my god, the value of x is 0 plus 1 as dictated by the equation, I think.
Yes.
Nothing changed here. Good to go. Now this is 0 plus 1, which is 1. It is 1. Crazy. So the value of y equals 1. Am I supposed to come and put it here?
Yes. Because the question is complete.
Can you please allow me also to do this? Because this seems easy.
It's my pleasure.
Oh, Roman numeral 4. Good. That y equals x plus 1. Crazy. Here we go. I'm having the value of y, which is 2. Substitution now. We have x? No. So it's x I'm looking for. Good. X plus 1. Here we go. Now we are getting 2 equals x plus 1. Now, how have you got this?
Additive inverse.
So now I have to subtract x, 1 on both sides.
Yes.
So I say 2 minus 1 equivalent to x plus 1 minus 1. Because I want to manage x on one side. 2 minus 1 mathematically is 1 equals x plus 0.
Yes.
Oh, this is x. Mathematically, x equals 1. Thank you.
Complete the table.
Now, let me ask you, what makes this number hard?
There's nothing.
This, according to me, I'm saying this is something very simple. What makes it hard? Maybe you come and explain from this side.
Yes. What makes that number very hard? What makes this number very hard?
Yeah.
Is this 2.
Alright.
When a child has no competence of algebra,
And where do
competence of integrals,
learners make mistakes here? Because this is something simple.
Yes.
But very many learners fail it. So I want to know that as learners are calculating, they are probably making a mistake here, and here, and they end up failing what they're supposed to be passing.
yes,
Okay.
as children are working out, we have mistakes here. From here, a child to identify that this is a negative 3 and then a positive 1. A child must be able to recognize this negative and respect it. If you don't respect the negative, you may find a child having a negative 3 plus 1 and gets a 4.
Alright.
So meaning a child must respect the negative and then a positive giving you the way I guided that we have a negative side.
So does
and
it
a
mean
positive side.
that kids make mistakes on that number by failing to solve the how have you called them?
Additive inverse.
Additive inverse.
Yes.
All right. Now, can you please give me 2 examples for that matter to show how kids can be helped to solve such an issue?
So for additive inverse,
Yes.
for example, I can say P plus 2 is equal to 4.
All right.
What we call an additive inverse, this one I would take this one to be an unknown.
Yes.
So meaning if I'm collecting like terms,
Yes.
we have integers come together,
Yes.
and then we have unknowns come together.
Yes.
So the integers, we have 2,
Yeah.
meaning we find the additive inverse or the correspondent inverse of positive 2. The opposite of positive 2 is negative 2.
Yes.
Do that on both ends.
All right.
That you have P
Plus 2 minus 2 equals 4 minus 2. That's very easy.
So
Yes.
that you have this giving you a 0.
All right.
You remain with the P.
Oh, come on.
2.
Teacher, excuse me.
Yes.
So the purpose of subtracting 2 on both sides is
Yes.
making sure P remains alone.
Uh-huh.
So even if I had P plus 10,
Yes.
I would say P plus 10 minus 10.
Definitely.
So as to remain with P
P
alone.
only.
Come
Collecting
on.
like terms. You
Good.
want the figures together, it's like you are sorting.
All right,
You
yeah.
want the X differently, and then you want maybe another property different.
All right.
Yes.
Can you grab and show us another example
Uh-huh.
of how a kid can be helped to sort the issue of algebra and integers?
Still, we have the issues of either negative.
I think we can wrap the whole work now.
Yes, you can have this off.
Yeah. We can have it off. Why for sure. Then mathematics seems to be a simple subject.
Very easy.
I wonder why I'm not a mathematician.
You will.
This is easy, man, you know. And now we can advance to, when we get done with this primary mathematics, we shall advance to advanced mathematics. Yes.
Now, children find problems with integers.
All right.
You find a child is having, assuming part A, solve negative 4, take away negative 6.
All right. Now,
I'll have 2 examples
yes.
to show these children.
Yes.
Ideally, this is a debt.
Yes.
You went and borrowed someone's money,
Yes.
maybe 4.
Yes.
You go back and you borrow.
Yes.
So you are going back to borrow. As you go to borrow money,
Yes.
meaning this person is going to add your debts.
Yes.
You will cut negative 4, take away negative 6. Meaning here, you're what? You are again borrowing.
All right.
Here I call for operation. Meaning a negative 4, you have to have a negative times a negative. Which is going to give you a what?
Let me zoom in and try to understand that properly.
Yes.
It's now fine. Yeah. Go on.
So you have a negative times a negative, which is giving you a positive.
That's mathematical principle.
Yes.
But the negative.
A negative
Yeah.
times a positive will give us a negative. Because a negative is a giant. But when you get a giant, multiply by a giant, again it will change to give you a positive.
That's crazy, man.
Then when you have a positive times a positive, since these ones are inactive, they remain there. But again, when you have a positive times a negative, negative remains a giant.
Yes.
So meaning, when you have a negative times a negative is giving you a positive,
Yeah.
go to the mind game method.
Yeah.
It's called the mind game method. You have a negative and then a positive.
Yeah.
How many positives? Positives are 6.
Yeah.
1, 2,
2,
3, 4, 5, 6. Then negatives 1, 2, 3, 4. You have a positive with a negative.
All right.
Positive with a negative.
Yeah.
Positive with a negative. Positive with a negative. Meaning
Oh, this is
you are
now
remaining
easy.
with only positive
2. That's
So
easy,
to
man.
write a mathematical statement is work for that person who is taking your work.
All right.
We'll follow through that. Okay, by multiplying here, you got a positive, and see the answer is remaining a positive.
All right.
Another one can be simplify positive 6, take away positive. I can say positive 4.
All right.
So meaning, still here, you have always look for one operation in between the integers.
Alright.
Here there are 2. Meaning, I will have positive 6, take away positive 4.
Wow.
The 2, I mean the other integer would be the 2 brackets to create an operation, and I look for one integer. So here we have positive 6, negative times a positive, we get a what? A negative. I explained this earlier here, that when you have a negative times a positive, you get a negative, you get a negative 4.
Alright.
So meaning, in the mind game solution, negative and then positive. So the positives are 6 and the negatives are 4. So
Alright.
1, 2, 3, 4. Then the positives 1, 2, 3, 4, 5, 6. So meaning, a positive marries the negative.
Yeah.
A positive and negative.
Yeah.
A positive and negative.
Yeah.
A positive and negative.
Oh.
A positive. Sorry.
Alone. That one keeps alone. Like that, yeah.
So meaning, by that simple mistake, that's what children, they enjoy. They get excited of circling and they enjoy, and then they go past what? The expectation act.
Alright.
So meaning, when I do that, I'm going to get my answer. I'm writing a mathematical statement. I remain with all the positives, and how many are they? 1, 2. There are only 2 positives.
Oh, thank you. Now, help me. Write down work exercise. 3 numbers.
Yes.
But of the same type, for someone who is watching us, for someone who is interested in our work, to practice as well.
Okay.
And I would suggest you also put answers in the brackets, such that when they are calculating and they don't come up with the answers in the brackets, then they have to recalculate, or maybe they seek our assistance.
Yes.
Alright.
Simple.
Now those are numbers for practicing.
Simple mind test.
Alright.
Part A is solve.
Help me try make them bigger.
Solve.
Like, no, it's okay.
Yes.
Okay. But you make the other work bigger.
Okay.
Yeah. Because some of our eyes, man.
Solve. Positive 4. Take away positive 2. Meaning, here you must come out with the answer as positive 2.
So if they don't find answer positive 2, then they know they are supposed to go back to the studio.
Yes.
It is crazy.
Simplify.
Yeah.
Negative 3.
Yeah.
Plus negative 2.
Yeah.
Meaning here we shall get the answer as negative 5.
So if they calculate and that's not the answer, they go back to paperwork and they recalculate.
Yes. Part C is work out.
Yeah.
Positive 5.
Yep.
Take away negative 2.
Now, the first case we had a number involving equation. I want the last number to be a number of that type.
Okay.
Thank you.
So here the answer will be positive 7.
Alright.
Number 2.
Hey, come on. If you calculate this and don't come up with positive 2, go back.
Yes.
If you calculate this, don't come up with negative 5, hey, you're wrong. If you do this and don't come up with the answer positive 7, come on, go back and calculate. And if everything fails, go down to the comment section, tell us about your issues, we can solve. We are wrong, come on.
Yes.
Come on.
Complete.
The table below. Good.
Using y equals x plus 2.
Alright. Good. This is easy, man. You're adding number 1.
Adding 1.
Good.
That's 1.
Alright.
This is x, this is y.
Alright.
On the previous example, assuming this is negative 4,
Alright.
then I assume this one is 6,
Alright.
assume this one is 1, and then this one is 3.
Now, to have someone who is going to do this,
Yes.
I want you to calculate answers in your mind. Put answers in brackets here, and here, so they can easily.
Here we shall have negative 2.
And that's the answer
As
after
you
the
work out,
Yeah.
then as you work out the value of y is 6,
Yeah.
here you get 4.
Oh, alright.
Here, the
You
value of
calculate.
y,
Yeah.
as you calculate out, come out with the correct answer,
Yeah.
you must have 3.
Alright.
And as you work out, this must be 2 brackets.
Yeah.
And as you work out, the value of y is 3, so to get the value of x must be 1.
Alright.
Yes.
So, boys and girls, ladies and gentlemen, whoever is watching this, downloading this, reading this, studying this for your own purpose, if you calculate and you come up with 1 year, then you recalculate.
Yes.
The same applies to this, and that. It's been a pleasure meeting you, and I'm happy. We have a grateful appeal. We have some good subscribers. If you're not subscribed to our channel, please subscribe and enjoy business. We can help each other understand mathematics. We are coming up with some things which are more complex than just this.
Yes.
So, thank you.
You're welcome.
Thank you. Thank
Our
you.
dear viewers, thank you very much. Goodbye.